Okay, working through a double slit interference problem. In a way, it's kind of like we've done questions before. We'll just pull out the information out of the question as we get to it. So reading this one over, lambda equals 650 nanometers. A nanometer means 10 to the negative 9, but we had hundreds of those, so that switches it to 10 to the negative 7. It says it passes through a double slit, hits a screen that's 3 meters away. The distance to the screen is capital L. And then there's this sentence, or this phrase, the distance between consecutive dark spots is 1.5 meters. So when the light goes through the double slit, hits the screen, we get this interference pattern on the screen. Let's say those red splotches are the bright spots where we see the red laser light. What the question is saying is that the distance from dark to dark, it doesn't say which dark to which dark, just that they're consecutive. So dark to dark is 1.5 centimeters. Double slit pattern is very uniform. If dark to dark is 1.5 centimeters, that means that bright to bright is also 1.5 centimeters. When we're doing an actual lab or when we're looking at the double slit pattern, sometimes it's hard to tell which one the middle, that reference line one is, but because it's so symmetrical, it doesn't matter. We can assume that this is our n equals 0 reference line, then the one right beside it is n equals 1. So if we know that dark to dark is 1.5 centimeters, we also know that bright to bright is 1.5 centimeters, and that basically tells us that the first bright spot occurs when y equals 1.5 centimeters. So we know n, we know y. This particular question is asking us for the distance between the slits. Since we've worked it out and used logic to figure out how far it is to that first bright spot, even though the question talked about dark spots, our logic got us to figure out where the bright spot was. We're going to use the constructive equation. In this equation, we know everything but letter d. So d is n times lambda multiplied by L all over y. The n by our logic was 1. The lambda was the 6.5 number. The L was given as 3. And our y value is the 1.5 centimeters. We put that in meters and get that. Crunch it out. When I do it, I get 1.3 times 10 to the negative 4 meters. So that's a fraction of a millimeter if we care, or just in scientific notation, meters is good. That's how we're going to work double slits. Pretty much all these interference questions, from what's given in terms of the pattern, the spacing of the bright, or in this case, dark spots, doodle a little picture and figure out what that's really